Hello guys, welcome back to lecture series on discrete mathematics. After long times guys, we are back here with a discrete mathematics lecture series. So we are planning guys to continue complete lecture series based on the discrete mathematics for SPPU second year computer engineering. So it is not only for the SPPU second year computer engineering, those students who are interested in set theory like group theory, ring theory, field theory, graph theory, such a concept. So this course is completely for these students. So from today onward guys, we are going to continue with the discrete mathematics lecture series. Here we upload entire concept with some of the important example from SPPU question papers. Okay, so without further ado, let's get dive into our today's lecture guys. So we continue discrete mathematics with the sets and proposition unit. Under this unit guys, mostly we are focusing on introduction and significance of discrete mathematics, sets, method of describing set, like a roster method, like a listing method, set builder method. This method we are going to learn here. Afterwards, methods of describing sets. Afterwards, we go for the some special set, subset, proper subset, types of the sets. After that, Venn diagram, operations of the set, algebra of a set operation, principle of duality, cardinality of sets, and principle of inclusion and exclusion. These are the major point we are going to learn underneath of this unit. So why actually we need a set and proposition in our computer engineering? Why it is included in a discrete mathematics? Actually, the notion of a set fundamental concept for the mathematics, and it is, and every branch of mathematics can be considered as a study of a sets, object one kind of another. Okay, actually the concept of the set which is developed by a great mathematician Cantor. Okay, he found the set theory and thereafter it got the lot more generalization. Okay, but actually the set theory, it is mostly important in a discrete mathematics for like a counting principles. There we need a set theory. That's why we are learning set theory. Okay, that is the sufficient introduction for our discrete set theory and proposition for discrete mathematics. We continue with the major point that we needed here in our discrete mathematics for our first unit. What actually meaning of a set, guys? You all have learned the meaning of set, relation function from your 12th or from your basic standards. Okay, so set means a well-defined collection of objects. That means you can define it, we define it well. Okay, so you, if you are going to define the set in well order, so that we call the set. Okay, so an object in the set called a member of element of the set. Okay, the object which is present in the set we call the member of set. Okay, and the set generally are denoted by capital letters. Okay, so set generally denoted by capital letter like A, like B, like C. These are the notation that we use to denote the set. Okay, for example, A can be denoted as under curly bracket A, B, C, 1, 2, 3. Like any number can be, that can be a well defined. Okay, so the object which can be the well defined, we call it as the set. Okay, like for if we take like a real life examples, the set of a professor in SPPU university. Okay, under SPPU university, how many professors are there, so that we can define well. Okay, so that when we call the set. Okay, or maybe the words in the mathematics. Okay, later so if we have mathematics word mathematics, okay, this is the word, so we can define this letter easily. Okay, so that's why we call the letter of words which is present here as a set. Okay, that we call the set. Yes, now here we have two to three notations, like a belongs to notation. Okay, that means how this belongs to notation works. For example, belongs to means the element which present into that set. Okay, for example, A, this small a belongs to capital A. Okay, this way belongs to notation works. That means A belongs to capital A. Okay, this is the belongs to. Now we don't have consider that Z. Okay, if a Z which is not present in this set, we write Z do not belong. Z does not belongs to set A. Okay, Z does not belongs to. That means A contain in capital A, so we use belongs to. Okay, so this is the belongs to symbol. And if any element, for example Z I consider here, which is not the part of A, so I return here as a Z does not belongs to set A. Okay, yes. or there we have there exists symbol also. Okay, so these are the symbol you already learn. Okay, so we use there exists symbol, that means there exists at least one element which is present in our set. Okay, that means we can write there exists a belongs to set A. That means there exists at least one element we have which present in a set. Okay, this is the meaning for belongs to and there exists. Okay, so this symbol we are going to use in our subsequent examples. Okay, there exists belongs to type of the set. Okay, yes. Now we have some methods that we describe the set. Okay, like a method for describing sets. Method. Okay, first method we know that the like a roster method, or we call it as the listing method also. Okay, first is the roster method and listing method, and next we have set builder method. We have next set builder method. Okay, these are the two major point where major type where we define the set. Okay, in simple language guys, always remember that the set which we can define easily. Okay, the set which we can define easily, we denote it as the roster method or a listing method. Okay, for example, I'm writing directly the example, we are not going like a definition, it is quite easy to understand this one. Okay, okay, the set which can be defined easily called as a listing method. Okay, for example, we consider like a set A, I consider as A, B, C, or any number, you can consider anything. Okay, that can be defined easily, that's why we call it as the listing method or roster method. Okay, so that one is very easy to define listing method or roster method. Okay, so set builder method. Okay, set builder method. Now let me, the set which we cannot define easily or denote like counting the elements, which is not that easy in that set. Okay, so in such a case we use the set builder method. Okay, for example, I will consider one of the example here. Example A set I will consider, okay, under curly braces, x such that. Okay, so take some properties. Okay, like x is a even number, any number you can consider. Okay, x is a even number. Okay, x is a even number, and one more condition on x, we want all x smaller than 100, strictly less than 100. Okay, so in such a case you can see that even number means 2, 4, 6, the number which can be divisible by 2. Okay, so 2, 4, 6, 8, 10, 12, and up to the less than 100, up to the 98. Now see that for writing or defining all these elements, it's not that easy in this set. Okay, so that's why we call it is the set builder method. So we use to denote the set by some of the property of elements. Okay, x is a given. Okay, that one is first property, and x should be strictly less 100. So this one is the one more property. Okay, that one we call the set builder method. Okay, yes, so we go for some standard sets which we needed subsequently. Okay, okay, some special set. Some special set. Okay, what are the special set? Okay, like a natural number, integer, then positive integer, rational number, real number, complex number. Okay, yes. So with I want you to understand these all the special set in under some one of the diagram, like we used to denote it as the Venn diagram. Okay, so let me draw one of the diagram here. So this one is the bigger diagram, so I'm taking big diagram because we are going to denote all the number system underneath of this diagram. Okay, yes. So now see that this is the entire our universal set. Okay, so mostly we call it as the set of complex number, set of complex number. Okay, so we denote by cap like a c, and back side it is the one line here. Okay, so we denote set of complex number in this way. Okay, and the number which is in the form of a plus ib. Okay, a plus ib, this is called the set of complex number. Okay, So under complex number we have all real numbers. Okay, complex number, it is coming inside real number. Okay, this is the set of real number. Okay, that means all real numbers are complex number. Okay, set of real number. Okay, we denote like this r. Okay, set of real number, this one is a real number, and we know that the all positive, negative, rational, irrational numbers are the set of real number. Okay, so under this set of real number we have set of rational number here and set of irrational number. This is a rational, we mostly denote it as the q, and irrational, q complement. Okay, this one is the q and q complement. Okay, set of rational number and irrational number. Rational number is in the form of p by q, where q not equal to 0 and p and q belongs to real number. Okay, this is the property of rational number. Irrational number means pi, like a pi, after that fractional number 0 0.7, 3, 2, 1, like a square root of 111 prime number, like such numbers. After that exponential, this type of the numbers we call it as the irrational number. Okay, so under rational number we have first whole number, natural number, after that integer. These type of the numbers are coming under rational number. Okay, one is the whole number, we denote it as the capital W. Okay, whole number, that means 0, 1, 2, 3, 4 up to so on, all the numbers are whole number. Second, natural number. Okay, we denote by capital N, natural number. Okay, third, integer. Okay, third we denote third we have integer. Okay, integer we denote it as the capital Z, that means plus 0, plus minus 1, plus minus 2, plus minus 3, all the numbers are integers. Okay, that is the all numbers we have. Okay, yes, this is the all some special set that we are going to use throughout this entire unit. Okay, so you supposed to understand. Okay, so I'm going to explain one more condition over here for the subset. That topic is still remaining, but one thing you remember, subset means all element of a set, one set which belongs to the another set. That's why we call that one set as a subset of another set. Okay, yes, now you can see here integer, natural number, whole number. Okay, so all natural number means the number which start from 1, 2, 3, 4, 5 so on. Okay, which is a subset of whole number. Okay, all natural number is subset of whole number. Natural number are 1 to infinity, whole number are 0, 1 to infinity. Then after that all whole numbers are a subset of integer. Okay, then after integers, all integer Z, 0, plus minus 1, plus minus 2, plus minus 3, all the integers are subset of a rational number Q. Now see that the Q means P by Q form, like we write 4 as also the rational, like 4 is a 4 by 1 also. Okay, that's why 4 is also rational. Okay, that means all numbers which belongs to the all numbers belongs to the rational number. All rational numbers which is a subset of a real number, and all real number is a subset of complex number. Okay, these are the subset of each other. Okay, no, not each other, this subset of this is this, and this all are the subset. Okay, also we call it as the proper subset. Okay, now see that there exists at least one element in a whole number which not in a natural number. There exists at least some number which not in whole number. There exists at least some number rational which is not in a Z. So this can be the proper set also. Okay, these are the definition we are going to continue in our next part. So here we have next point, subset. Okay, so it is very easy, that we already defined in our previous example some special sets. Okay, so that definition we are going to continue here for the subset. Okay, what is meant by set? Okay, set A is said to be subset of B. We denote this one as a like this symbol. Okay, subset denoted by this way. Okay, set A is said to be subset of B if every element of a set A every element of the set A is also the element of a set B. Okay, if this condition hold, then we write this one as the subset. Okay, always remember that there exists at least one element. Okay, so let me write the property for subset. So first property I explain with the subset. Okay, so A is a subset of B. That means all element of a set which is in the set B. Okay, all element of set A which is in the set B, but there exists at least some element in B which is not in A. That means we write A not equal to B. Okay, that means A is having all the A is having so many elements, but they all belongs to the set B. But there exists some element in a set B which is not in A. That's why I have written A not equal to B. Second, I can consider here A can be equal to B. Okay, that's why A is a subset of B. If A is equal to B, then we write A is a subset of B. That means all element of set A which belongs to set B. That's why we call the subset. Okay, so this is very easy, guys. I already explained with some of the example. Okay, yes, so we go for the next part. Okay, so if you want example for this, you can take anything like A as 1 2 and B as 1 2 3. Now you can see that set A and set B both are not equal, but the all element of a set A which is in the set B. Okay, this is the property that you can consider for the first one. So this one can be possibility, and second one A which is equal to B, but these set are not equal. So A which is equal to B, that means you can take A as 1 2 and B as 1 2. Okay, so these two sets are equal. Okay, now we go for the next proper subset. Proper subset. Proper subset. Okay, proper subset is very easy, guys. Okay, proper subset we denote like this way. This is, we do not have one straight line below here. Okay, we have this symbol as a proper subset. Okay, so when we call the proper subset, okay, set A is said to be proper subset of a B if there exists at least one element in a set B which is not in a set A. Okay, we call A is proper subset of set B. If A is a proper subset of a set B if there exists at least one element in a set A, there exists at least one element in a set B, there exists at least one element in a set B which is not in a set A. Okay, there exists at least one element in a set B which is not in a set A. Okay, that's why we call it as A is a proper subset of B. For example, let me explain. So here you can take this example. Okay, there exists at least one element as a 3 which is not in a set A. Okay, but all the element of a set A which is in a set B. That's why we call it as the A is a proper subset of a B. Okay, let me take one example. A as a A1 2 and B as a AB1 2. Okay, now see that there exists at least one, maybe these elements can be many more. Okay, but at least one element in a set A B, there is at least one element in a set B which is a small b here, which is not in a set A. That's why we write A is a subset of, A is a proper set of B. Okay, proper subset of B. I hope you all have understood the meaning of a proper subset. Okay, yes, so I hope you all have understood, guys, these many definition. Okay, so this is enough for our today's lecture. I don't want you to take this lecture for longer. Okay, so remaining part will continue in our next lecture, guys. That's it for our today's lecture. I hope you all have understood my today's concept. Okay, we are starting from the basic. Once we go further and further, you will get the more little advanced concept. Okay, that's it here for our today's lecture, guys. Thank you so much for my today's lecture.